Hello and welcome to the 7th video in our series on Advanced Trigonometry. I'm Mr. Chowdhury and today we're going to be looking at the cosine rule. Now if you hadn't already seen our videos on the sine rule, I suggest you go and watch them first and then come back to this one. But if you have and you're up to date, then let's have a look at this first question. This first question is, can we use the sine rule on this triangle? Can we use the sine rule on this triangle? I'd like you to pause the video and have a go. Okay, so if you answered no, you are correct. You cannot use the sine rule for this question. And that's because to be able to do the sine rule, we need opposite sides and angles. So for example, on this question, we have a 40-degree and our x. So they are an opposite side and an angle. We need two pairs of those. So we have 14, but we don't have the opposite angle. And we have 12, but we don't have the opposite angle. And there's no way for us to figure out those opposite angles. So instead, we use what we call the cosine rule. Now the cosine rule looks something like this, and I've picked this particular version of the cosine rule for a reason, and I'll talk about that in a second. But for now, this is what the cosine rule looks like. If you are interested in where this comes from, I will be making another video on the proof for the cosine rule, so be sure to go check that out, and that should help you understand where this comes from. But for now, what we're going to do is look at this equation and then start using it to solve some questions. So let's have a look at this question and we're going to start using it to solve it. So I write down the cosine rule. The key thing to remember is the angle that I've written here. So the letters don't actually matter. I could have had it as a squared equals b squared plus c squared minus 2 bc cos a. I could have had it like that. I could have had it with a b squared instead of a c squared at the beginning. I could have done it like that. But the reason I've chosen to do it this way will become clear in the next slide. But for now, what we need to know, the key thing that we need to discern from this is that the angle is called c. We need to name the angle that we are given c. So here we are. I've labeled the angle that we're given c. And by using our triangle naming conventions, I know that our unknown is also going to be c because it's opposite our angle. Now a and b don't really matter because we're going to add them anyway, and addition is commutative, so whichever way we add them we'll get the same answer. So we're going to label 14 as a and 12 as b, and then we're going to substitute in our value. So all I've done is taken my equation and substituted in our value. So instead of c, I've written x, instead of a, I've written 14, and instead of b, I've written 12. And I've done that throughout the whole question. And obviously, instead of cos c, I've written cos of 40 because our angle is 40 degrees. Then I need to start doing some calculations. So I'm going to do some calculations. So what does 2 brackets 14 brackets 12 cos 40 mean? Well, that means 2 lots of 14 lots of 12 lots of cos 40. It's also very important to know that we need to do the 2 times 14 times 12 times cos 40 before we subtract it from 14 squared plus 12 squared. We need to do all of this calculation first. We need to evaluate this right hand section before we subtract it from the left hand bit. So then that's what I've done. I've worked out what 14 squared plus 12 squared is. And then I've worked out what 2 times 14 times 12 is, which gives me 336. And then I've multiplied 336 by cos 40. And then I've done the subtraction. Now, right now, I have not answered the question. X squared is equal to 82.609, and then the rest of the decimals. I need to answer this question. So to answer the question, I need to square root it and then round it at the end. I haven't rounded as I've gone through because I want to have the most accurate answer. I could have rounded at this step here. I could have rounded to like 5 or 6 decimal places if I wanted to make it easier. I chose not to. I chose to keep that value on my calculator because I'm confident with doing that. And that's what I got as my answers, 9.1. Now, I could have just substituted this section. So x squared equals 14 squared plus 12 squared minus 2 times 14 times 12 times cos 40. I could have just put that in my calculator and then square rooted it to get directly to this answer, but I like to split up the steps so I know exactly where I make a mistake if I do make a mistake. I'm not saying I would, but if I was to make a mistake, I'd know exactly which step I made a mistake on if I write out my steps rather than just putting this into a calculator and pressing equals, because then if I make a mistake, I don't know where I've made it. Now, I'm going to give you something that's very interesting that you should also know. Now, what happens if we change this angle? So I've changed that angle to 90 degrees. And let's see what happens to the working and how the working changes because I've changed it to a 90 degrees. By changing this to a 90 degrees, I've turned this into a right angled triangle. So I write the cosine rule again. I label my triangle exactly as I did before. I substitute in my values. Once I've substituted in my values, I notice that I have cos 90 here. Now, if you remember our exact values of trig lesson, we know that cos 90 is equal to 0. So I will end up with 14 squared plus 12 squared minus 2 times 14 times 12 times 0. Well, if we look at this 2 times 14 times 12 times 0, because I am multiplying by 0, this calculation ends up giving me an answer of 0. So I end up with 14 squared plus 12 squared minus 0. Which means I end up with just Pythagoras' theorem, because if you think about it, I have c squared equals a squared plus b squared, because the minus 2ab cos c part of the equation becomes 0, and I can just solve this like I would solve Pythagoras. So it's really important to note, as a memory aid and just as a general understanding of the cosine rule, the cosine rule is Pythagoras with a bit subtracted from it. The cosine rule is Pythagoras with a bit subtracted from it, because like I just showed you, if my angle was 90 degrees, 2ab cos c would just give me a value of 0, which would leave me with just Pythagoras. So it's a good way to remember it as Pythagoras with a bit subtracted from it. The bit that we subtract from it is what makes it applicable to non-right angle triangles, because you already know Pythagoras' theorem, c squared equals a squared plus b squared. Now that we've done that, we can look at when we can apply the cosine rule. So here we're going to play a game called Can We Apply the Cosine Rule? So I'd like you to look at this triangle, pause the video and tell me, can we apply the cosine rule and why? If your answer was no, you are correct. We cannot apply the cosine rule because we are only given 2 sides. We need 3 sides and 1 angle to be able to apply the cosine rule. Because if we were to label these, we'd label this as C, the 40 degrees is C, but then the opposite side has no value, so we don't know what it is, so we can't apply the cosine rule. Have a look at this one. Can we apply the cosine rule? The answer is no. Even though the orientation has changed, we only are still given 2 sides. We need 3 sides to be able to use the cosine rule. What about this one? The answer to this one is yes, but we wouldn't use the cosine rule here because it's a right angle triangle, and in that situation we would just use Pythagoras. Remember, Pythagoras is for right angle triangles and the cosine rule is usually used for non-right angle triangles. That does not mean you cannot use it for right angle triangles, it's just inefficient to do so. Okay, and your last one? The answer is no. Once again, we need 3 sides and 2 angles. In this question, we would use the sine rule because I've got an opposite side and an opposite angle. And the last one. The answer is yes. However, it's slightly different than what we have looked at so far, because if we were to label this triangle and substitute in our values, you'd notice that we end up with our unknown being part of the equation rather than the subject of the equation, which means we'd have to do some rearranging, and that's going to be in our next video. So be sure to watch the next video to understand how to answer questions where the unknown is part of our formula rather than our subject. So to summarize, we need to know the key characteristics of the cosine rule, and the key characteristics are: we have 3 sides and exactly 1 angle. One of those sides could be an unknown. The angle could be an unknown. As long as we have 3 sides and an angle, we can use the cosine rule. And the other thing to remember is it's typically used in non-right angle triangles. We can use it in right angle triangles. However, it's significantly inefficient to do so. So what I suggest now is, if you are happy with this video, you go away and you practice some questions. You can go watch Mr. Amison's video, which will be really helpful for you. You can, if you are super confident, go on to Corbett Maths and Dr. Frost and practice some questions. Hope this has been useful for you, and I'll see you in the next video.